Good afternoon, everybody. Thank you for joining our webinar. Today we will show you a new solution for supporting CAP activities that has been developed and prepared by my colleagues. But first of all, I'd like to introduce them to you. Here with me today, I have Jan Musiał and Jędrzej Bojanowski. Jan and Jędrzej are our senior data scientists in CloudFerro. Jędrzej will also moderate the chat, so during the webinar, feel free to ask questions in the chat. After the main part, we will have a Q&A session to answer questions that were not handled in the chat box. Here is our agenda. Today, mainly, we will talk about SatCAP on every aspect. And at the end, we would like to talk a little about EO for UA initiative, which is related to current situation in Ukraine, which is impacting their own agriculture, but also in the global scale. Right now, I'd like to pass the voice to my colleague. Jan, please continue.
Hello, everybody. So today we will, as introduced, we will show our solution towards new CAP policy, which builds on the EOSTAT project funded by ESA and conducted by the Institute of Geodesy and Cartography and Polish Space Research Center. Within this project, a custom area monitoring system for the Polish Bank Agency has been developed and deployed on the CREDODIAS platform operated by CloudFerro, and now we are managing the system for our bank agency. SatCAP is now a new system that evolves at CloudFerro and are managed by us. We're also a part of the EOSTAT consortium. SatCAP is a complementary solution to the SEN4CAP system, which you have already seen, and it's available on our CREDODIAS platform. And basically, we tried within our system to address some problems or issues that we encountered when working with our bank agency. And basically the SatCAP provides information about crop type classification, and this is based on a fusion of Sentinel-1 and Sentinel-2 imageries, agriculture activities, and these are the greening and harvest dates of the main crops and the catch crops, without the need for the reference data, as for example in SEN4CAP L4C processor, because in Poland we don't have any reference data on this, so we had to develop another solution towards this problem. Detection of agricultural fields susceptible to erosion, and this is another product. Early detection of winter and spring crops, and detection of unmanaged meadows. Also, our system generates the PDF reports that are accessible through the HTTP web protocol, so they can directly use to justify payouts. And SatCAP generates reports and updates the Postgres database very frequently, every 3 to 5 days, basically, when the processing ends. And what we offer to our clients now is testing of the SEN4CAP system for free in 2020 for some limited number of users and for the specified AOI. And if you feel interested after the presentation, please contact me or the sales at cloudferro.com. So a few words about agriculture in Poland. We have more than 4 billion euro donation from EU in 2019. The arable land is very large. It's almost 15 million hectares. We have 14 million farmers, over 10 million agriculture fields, and 1,500 agriculture holdings. And on the right hand side you have a table which shows you where we are within the EU. A brief methodology how we developed our product. So basically, the red lines here are the farmers' declaration from LPs, and what we do, we make a 15 meters buffer from this red line. So these are the green lines, and we do so in order to tackle the problem of mixed pixels at the field borders or some hedges or trees, for example, which are planted along the roads or fields. And here, these are the same things, but after rasterization. So as you may see, some of them are not covered anymore. So these are too small fields to be analyzed. And here we have our product. So this is one of our products. This is the vegetation cover mask. On the left hand side, we have an RGB imagery somewhere in spring. So at the very top, you can see a agricultural field which is fully covered by vegetation. So here you will have a fractional vegetation cover equals 100. Below there is only soil, bare soil, so there will be vegetation cover 0. And at the very bottom there is a field with mixed pixels. So there is a little bit of vegetation, but also a little bit of the soil. And here you will have some values between 100 and 0. So as I mentioned, we generate reports which can be used to justify payouts, and this is basically our main product. On the left-hand side, you can see on the y-axis the vegetation fraction. This is the red line taken from the Sentinel-2 data. The small red stars denotes the satellite acquisition dates. And then you have the vegetation indices such as EVI or NWE, and these are the purple and gray lines. And on the right hand side, you have Sentinel-1 data. So this is a sigma node, but not in the logarithmic decibel scales, but with the normal scale. And here you have the VV polarization and VH. And based on analytics of those data, we determine the greening and the harvest date. So this is the green line, vertical one here, and the orange line. And these are the dates of the agriculture activities, plus minus the day, how many days was before and after acquisition. And there are some metadata about the ID of the farmer, or ID of the field, classified crop. So this is the crop type that comes from our system, and the declared crop. So this is the declaration of farmers. And on the right hand side, you can see the some data about the location of the fields, the size, the area, elongation, inhomogeneity, and about the type of soil. So here we have a classified crop was winter rye, but the declared crop was corn. And as you can see clearly here that this plant emerged somewhere in autumn, so it couldn't be corn. So this is a false declaration, whereas here for corn this is the correct declaration. You can see that it emerges somewhere in June, and it was harvested somewhere late September. And this is another important notice that I would like to make about the crop type classification, because many of agencies or our companies that we work with have this kind of an approach that they think once they give the data, they will get very good results because they attend many seminars, Sen4CAP seminars, and they could see that the crop classification is very high. But basically, the crop type classification comes also from the quality of the LP's data and also about the from the categorization of the and grouping of the crop types. So even if you have very good classifier and you will feed it with the inseparable classes, you will get very low accuracy. That's why it's crucial to make a lot of tests to see which crop types should be grouped and which crop types couldn't be classified using the remote sensing data. And basically, the message here is to do it as fast as possible. Do not wait for the next year. And we can help you in doing this kind of analysis as well. So a few words about technical implementation of our system. So everything is deployed on the CREDODIAS as a virtual machine with running on Ubuntu. Here we have Sentinel 1 and 2 and LPIS data. Then we have our Python scripts that process this data. We have then the results goes to the Postgres and PostGIS database. And basically the database is the heart of our processing system. So then users may access it using the API. So they can directly access the Postgres or PostGIS database via some queries, or they can use WMS, which is served by GeoServer, and use this to visualize the data as a geoportal, or they can put this WMS into the QGIS or other GIS software and run the analysis for themselves there. So this is the Postgres database with PostGIS. So all the results are stored here. This is the web interface, and we have a custom geoportal that allows our clients to visualize this product. If I will try to show it in a web browser now, hopefully it will work. So basically, these are the fields, and when you click, you can see the declaration, and here you have also labels with the declared crop type. So you can also put here, for example, the catch crop or the winter crop to visualize which fields are covered by this kind of crops. And yes, there are some background layers served by our national geoportal. So here you can see, if we zoom in, that this is for the whole country. And moreover, there is also at the very beginning, if you go, then there is a login page. So this kind of information are not public. So there has to be a username and password to protect the LPIS data. So yes, I will try to go back to the presentation now. Okay, so this was our geoportal. As I mentioned, you can put those layers also into the QGIS interface. And what kind of challenges we also face in Poland? First of all, it's the problem of small and big fields. So basically around 50% of all agricultural fields cannot be monitored by the, let's say, Copernicus data because of the resolution. And only 20% of they compose 20% of the total acreage. And that's why we were making tests with higher resolution imagery. These are the location of those small parcels. So usually they are located in the southern Poland, where we have mountains and more rough topography. And what we also implement in our processing system, we are now doing this frankly. This is to implement the enhancer product. So this is the product that is available also on our CREDODIAS platform. So out of 10 meters, so we are making 2.5 meters image, and we use this also to run analysis and to generate those reports. And this brings me briefly to conclusions. So our SatCAP system is a custom area monitoring system for Poland, but now we are offering it also to our countries. But first, we would like to run some tests. So if you are interested, please contact. So the system originates from the ESA-funded project. SatCAP is complementary to the Send4Cap system, available also on the CREDODIAS platform. So here we don't want to reinvent the wheel. Basically, the functionalities which are in the Send4Cap system are still there. But here, for example, we had to develop some custom approach towards problem with the agriculture activities detection. In Poland, we don't have any reference data, so we made our custom approach. So CloudFerro system uses Sentinel-1 and Sentinel-2 radar and optical imageries combined with ancillary administrative data and data about the soil classification. The system also constantly reprocesses data whenever a new system Sentinel image is available. So this is kind of a different approach than in Send4Cap, where there you have to specify it when the data or the products will be generated. Usually it's middle of the vegetation season and further on. And here our approach is to regenerate it every time we have a new data. So the heart of the system is based on the QGIS, is based on the Postgres database, which allows a verticile access through the GeoPortal, QGIS, WMS, SQL query, etc. And our system generates reports that can be directly used as a justification for payouts. CloudFerro also optimizes and manage the entire system. So basically what we expect from the clients is just the LPIS data, and then we produce the ready-to-use products for our customers. Currently, we are adjusting the system to work with the Sentinel-1 super resolution imagery in order to tackle the problem of small fields. And as mentioned, CloudFerro offers testing the system for free in 2022. So if you are interested, please contact me. And the last thing that we would like to introduce is our EO4 UA initiative. And basically, the tragic events that happens now in Ukraine, and somehow we want to contribute also and to help the Ukraine and international authorities to monitor and also assess the war losses or war damages that happens now in Ukraine. Ukraine basically is a huge agricultural country responsible for 10% of the global wheat export, 13% of global corn export, and more than 50% of global sunflower oil export. So once due to the war, the agriculture activities will be limited, or some arable lands will not be cropped at all. So what we would like to do is to gather experts from market and also interested people to help to assess the arable land reduction, crop damage, and crop yield forecast, potential decrease in crop condition caused by reduced fertilization and agriculture activity, crop type classification, land cover change detection, or water bodies monitoring and drought detection. And we are also open to other ideas. And what we will offer is the access to the CREDODIAS virtual machines and EO data repository, SatCAP or SatCAP products for Ukraine, supporting in establishing your own data processing chains or CREDODIAS, or even support in implementing your own ideas on our platform. So currently we are looking for partners, so if you would like to join this bottom-up initiative, which hopefully will be funded from some international data source. So if you feel that you can contribute and help people in Ukraine by providing some remote sensing analytics, so please then contact me or my colleague at CloudFerro.
Okay, so thank you for coming to the webinar in such large numbers. Recording of the webinar will be sent via email with all the questions. If you have any question about any of the CREDODIAS or the CloudFerro service, please contact us via email. Also, you can always reach us on every social media like Facebook, LinkedIn, or Twitter. Please also visit our YouTube channel and watch our few previous webinars related to the SatCAP and, of course, related to other CloudFerro and CREDODIAS services. Thank you for today. I hope that we will meet again on next webinar.
Okay, thank you very much.